Hello everyone. In this tutorial, you'll learn how to create a linear steady-state heat convection analysis, create materials from scratch, define heat flux and convection as boundary conditions, visualize temperature gradients, and create a response for total heat flow rate. First, import the heatsink.gda model. You can simply drag and drop. Create the thermal solution under the thermal physics section, then heat transfer. Set solution type to steady state. Select all bodies and make sure to have create tie contacts enabled. Let's review our contacts. Right-click on contact, then review. Check each contact was correctly created by selecting the corresponding contact name. To create our material, select material, then create. First, we're going to create aluminium. Set the following properties. Density of 2,770. Thermal conductivity of 0.22. Heat capacity of 0.009. And free convection of 1.3. Hit apply. Next is copper with density of 8,933. Thermal conductivity of 0.401. Heat capacity of 0.000386. And free convection of 3.8. Lastly, insulator with density of 1,020. Thermal conductivity of 3.5 e to the minus 5. Heat capacity of 0.0041. And free convection of 0.17. Go to the assembly browser and assign the materials as follows. For fin, assign aluminium, cylinder assign copper, and insulator assign insulator. Let's set our boundary conditions. First, assign heat flux only on the inner surface from the cylinder and set a heat flux of 100 watt per square meter. Apply our convection. First, select only the fin surfaces. For this, set the view to the ZX plane and use the rectangle selection as shown to select the fin faces, not including the symmetry cut. Set the temperature to 35 degrees Celsius and film coefficient of 1. Right-click on Settings, click on Result Request and make sure both temperature and flux are enabled. Hit OK. Right-click on Results and select Update to start the solution. First, we can see our temperature grid. Go to Component and change it to Temperature Gradients. Return to Temperature Grid Visualization, and let's create our response. Right-click on Results, go to Response and select Total Heat Flow Rate. Right-click on Convection Select Entities to get the total heat flow rate for the fins.